The World Health Organization recommends we keep free sugars under 5 to 10% of our daily caloric intake to stave off chronic diseases like type 2 diabetes and heart disease. We struggle to meet that target because human evolution hardwired our brains to aggressively seek out sweet-tasting, energy-dense foods. In nature, sweetness signaled safe, immediate energy. This anatomical diagram shows exactly how that detection happens. Down in the taste buds on your tongue, specific G-protein-coupled receptors, known as T1R2 and T1R3, identify sweet molecules. Non-nutrition of sweeteners are chemicals shaped to bind with those exact receptors, triggering the electrical signal for sweetness. The brain receives the message and registers the sensory pleasure of eating sugar, but the body never receives the actual metabolic energy. While hacking our taste receptors solves the caloric problem, it creates a massive functional problem once we move from the lab to the kitchen. The most common mistake consumers make is assuming all zero-calorie sugar substitutes behave exactly the same way when poured from a packet. Ordinary table sugar performs 3 distinct physical jobs in cooking. It provides sweet taste, it delivers metabolic energy, and it provides physical structure, meaning bulk, moisture, and browning. This chart shows the massive variance in sweetness potency among the alternatives. Synthetic compounds like aspartame and plant extracts like stevioglycosides range from 100 to 400 times sweeter than sucrose. If a recipe calls for a cup of sugar to create physical volume, and you swap in a cup of a high-potency sweetener, the result is a total structural failure. The batter will collapse. You also lose sugar's ability to retain moisture, leaving the crumb dry. And without sugar to trigger the Maillard reaction, baked goods emerge pale, unable to achieve a browned, caramelized crust. Successfully choosing a sweetener requires ignoring misleading marketing labels and instead categorizing these compounds by their chemical behavior, their volume, and their heat stability. To evaluate our options, we can map them on a 2-axis framework. We will plot their metabolic and gut safety against their culinary versatility and heat stability. First up are the legacy synthetics. This category includes aspartame, sucralose, and saccharin. The primary appeal of these lab-created compounds is economic. They are extremely cheap to produce and highly potent, requiring only microscopic amounts to flavor a diet soda. But aspartame possesses a critical structural flaw. It cannot survive heat exposure in cooking or baking environments. When temperatures exceed 150 degrees Celsius, aspartame chemically breaks down. It loses its sweet properties entirely, degrading into non-sweet compounds. Sucralose survives heat better. It avoids an immediate blood sugar spike because its chemical structure, modified with chlorine atoms, passes through the digestive tract largely unchanged. However, emerging scientific research suggests that long-term sucralose consumption may negatively alter the gut microbiome and induce glucose intolerance in some individuals. Legacy synthetics are effective for cold drinks and tabletop packets, but their heat instability makes them useless for bakers, and their chemical footprint poses potential long-term risks to gut health. Next is the plant-derived category. Extracted from sources like stevia leaves and monk fruit, these are marketed as clean-label alternatives. Basic stevia extract, known chemically as Reb-A, boasts high heat stability and delivers a sweetness roughly 250 times stronger than sugar. But basic stevia comes with a biological drawback. The molecule cross-activates the bitter taste receptors on the human tongue. This sensory overlap leaves consumers with a persistent, metallic, or licorice-like aftertaste that lingers long after the sweetness fades. To solve this, the industry developed premium upgrades, specific extractions like monk fruit's Magroside V and stevia's advanced Reb-M compound. These highly refined extractions eliminate the bitter crossover. They achieve a clean, sugar-like taste profile while maintaining a pure zero glycemic index. The trade-off is financial and physical. These premium extracts are incredibly expensive to scale, and because they are so potent, they provide zero physical bulk unless a manufacturer mixes them with a cheaper carrier ingredient. Plant-derived sweeteners offer a clean-label, zero glycemic solution, but achieving an authentic sugar taste without the bitterness requires a high financial cost and precise recipe manipulation. The final category plots out to the far right. These are the polyols, or sugar alcohols, substances like erythritol, xylitol, and maltitol. Polyols differ from high-intensity extracts in one crucial way. They are bulk sweeteners. They physically occupy space in a mixing bowl, providing the volume and structure of ordinary sugar. This grants them distinct culinary advantages. They possess excellent moisture retention, high heat stability, and the structural integrity necessary for true baking. Their primary sensory limitation is potency. They possess roughly 60 to 80% of ordinary sugar, which means you have to use larger volumes to hit the same flavor notes. Their metabolic pathway dictates their effect on the body. Polyols absorb very slowly in the gut, resulting in a very low, or sometimes absolute zero, glycemic index. But that slow absorption triggers a trade-off. What isn't absorbed in the small intestine passes to the lower colon, where it undergoes heavy bacterial fermentation. This infographic details the clinical results of that fermentation. You must enforce a strict 50 gram per day consumption limit. Exceeding that threshold leads to severe bloating, gastrointestinal distress, and acute laxative effects. Polyols are an indispensable structural tool for the home baker, but they mandate strict portion control to prevent digestive issues. With the chemical data mapped, we can run a branching protocol that matches your specific health constraints to the correct class of sweetener. Scenario 1 is the metabolic optimizer. This path targets diabetics, keto dieters, and anyone actively battling insulin resistance. To guarantee an absolute zero glycemic response without risking gut health, this profile must rely on pure, high-intensity plant extracts. The crucial caveat here is packaging. You must aggressively check ingredient labels for hidden carrier powders, like maltodextrin, which manufacturers use to bulk out the packets. Maltodextrin has a higher glycemic index than table sugar. Scenario 2 is the healthy home baker. This profile needs the culinary structure of sugar without the caloric load. The solution is a hybrid. Blending erythritol for physical bulk with monk fruit for intense sweetness creates an ingredient that survives a 400-degree oven perfectly, maintaining both structure and flavor. But bakers must remember the chemical traits of the blend. Erythritol causes a slight mouth-cooling sensation, and the 50-gram limit requires you to restrict your portion sizes of the finished dessert. Success requires matching the specific chemical properties of the sweetener to your exact end goal, rather than blindly swapping ingredients. Scenario 3 is the clean label consumer. Their primary directive is avoiding synthetic chemicals and potential toxicity altogether. To ensure long-term microbiome safety and peace of mind, they must rely exclusively on natural plant derivatives. Their trade-off is a commitment to significantly higher grocery bills and dedicating time in the kitchen to trial-and-error blending to mask the bitter aftertastes of unrefined extracts. We also have to acknowledge the hidden cost of all sweeteners. Extracting these intense compounds requires massive agricultural processing and a heavy ecological footprint. The core scientific reality is unyielding. A perfect, compromise-free, one-to-one drop-in replacement for sugar does not exist on Earth. We have to move past the search for a perfect replacement, master the biological trade-offs of these compounds, choose the exact right tool for your specific scenario, and remember that moderation is the only strategy that consistently works.